Hello and welcome back to second part of our basic training for Datasmith, creating the DMO nominal file translator. So in the first part we looked at how to load a data file into a blank translator, how to save off the translator with a description into a network folder, how to load in a data file. We chose the method of clicking here on Add Files and then loading a particular data file for the DMO right here from the DMO nominal file folder. That's one method. Another method would be to click here on Data Files, and then where it says Config A, we can right click and choose Add Files. It would do the same thing of taking us to our network browser in order to grab or find the location of the file that we want to scan. Also, we looked at instructions, how to create some instructions, what the four basic methods or 4 steps of scanning data in Datasmith were, which was going to the beginning of data, start scanning, go to the end of data, and stop scanning or marking. And we followed those 4 basic principles to create our instructions to scan the area for the header and then for a characteristic within that header, which in this case was the routine name or the unique ID under which all the data here would be collected. So we're going to continue on here with this DMO file. One thing to realize, in most or in some cases, you will have a collection file or an output file. It will contain 2 types of data. It will have what is known as nominal data, which is all the measured locations on your part, all the X, Y, and Z or other nominal information for what the perfect part would look like. It would contain that information and perhaps also the measured data as well, what was actually recorded at those locations, so that you can compare that to what the nominal value is or what that measured value should be. There are a lot of files where both are included together. In this example, though, it has both types of information, but sometimes a company might have one file that's used specifically just for the nominal information, and then they might have another file that or another type of output that has a different format for the collected or measured data. So we're going to kind of consider that case here. This file that we're developing so far is simply for nominal information. So if that's the case, the only or the most necessary thing we need in the header is simply the routine name in order to have a record entered into the database for this routine or this data. So we have the routine name. What we'll do is look at the output or the actual measured information in the file. If we notice, it seems to start right after the highlighted header area. It says here output /F, and then we have a string of characters, which is the feature label for this one check. After that, it has another line where it has a call out called edge in Cartesian or CART, and then some numbers which represent the Y, the X, the Y, and the Z deviation. So one thing to know is if you're creating a Datasmith translator, you'll have to collaborate or talk to the customer who you're working with in order to find out what type of information is in the file and how it's formatted. That way you know what to look for when it comes to consistency in order to write proper instructions to grab each feature and the data for each feature. So it's good to discuss what the formatting is and where information can be found for the points in the file beforehand. In this case, I know that for this type of file, we have features going from top to the bottom of the file. This entire file will be considered one sample or one complete collection on this part with this name. And the beginning of information about one feature seems to appear where it says output/F, and then we have the feature name. The next line we have information about the XYZ nominal, and then the lines underneath that seem to be about the tolerances for that X, Y, and Z information. And then after that, it repeats, it says output, in this case FA, and then repeats information. But if you notice, the two feature labels for both areas are the same. Here we have E5218M0016, and that repeats below. So really what's happening is they're declaring the nominal information in the file first, and then what the measured value was here. But like I said, in this case, we'll just look at the nominal information and use this file to load nominal data. So the only thing we are really interested in is where the nominal information is located and how that repeats. So looking at the file format, it looks like we have output/F, then nominal data, and then the next time we see something like that is here for this other point, output/F, a new point name or feature name, then there's nominal information tolerances. So it seems like the beginning for every location where there's a new nominal information for a feature starts with F and then parenthesis the feature name, and then it seems to end where it has output, because if you notice it says output here for FA, and then you have the FA information or the actual information. So that being said, it looks like for this format, what's consistent is that each feature starts with output, and in the end, underneath it, the new feature, whether it's the same feature with actual information or completely new feature, there's the word output underneath it. So we can use that as a key in guiding us how to write the instructions to pick up all of the features in this file. So as you see, there's a lot of features within here. Thankfully, we only have to write one set of instructions, and the software is designed to repeat those instructions throughout the entire file until the end in order to pick up all the features. So we don't have to write instructions to pick up every one specifically. So to do that, what we'll do is go to the next section here that's relevant for the features. It's called features. We'll expand that. If you notice, there's a default one here already called feature A. If we right click and say modify, this will just be a name that we can change. So in this case, we can call this nominal data perhaps, and if you want to pick a different color, we can click on color and choose whatever color you prefer there. Okay, so we have that. Now what we'll do is expand instructions, and like we did for the previous case, we'll write our instructions to tell the software where to go to pick up the data, but we have to do it in a way so that when it repeats, it will do so throughout the entire file. So if we wrote the instruction to pick up this first feature, what we could do is first realize that when you're in features, For this first instruction, the cursor for this, or the location of that, will always be at the end of the header section. So for this first instruction here, our cursor would be right here. So if that's the case, what we could do is tell the first instruction, search for the next string, and I'm going to put the word output. And not just output, but output /F. And I'm going to do it in all caps, but if you want, you could turn off the casing and say ignore case and put this in all lower cases. It would still find that expression. So I will search for the next string one time. I'm not going to ignore case. I'm not going to constrain to that first line so that it can drop down and continue the search. So it's going to find it the first time it sees it, which will be here. If that's the case, that's going to be the beginning of this feature. So the next instruction will be mark current position as begin. So that sets this position as a beginning mark. What we want to do is get to this position here and make that the ending mark. But like I said, the end of this feature underneath it is another output. So what we could do is say search for, and actually I think what we'll do first is move this from this location. If I do a search for the next string output, seeing as it's already here at the beginning, it might see this as output and stay there. And what we wanted to do is search for the next one underneath. So what we'll do is tell this here. You can say move to the next line one time. Do not constrain. This will drop the cursor to the next line here. At that point, if we tell it to do another search for the word output, it will search through this and stop here. So I think that's what we'll do. We'll say for the next instruction, search for the next string output /F. That will put our cursor here at the beginning of this output, which is fine. At that point, what we could do is simply say mark current position as end. Now, if you notice, it's marking each area, even the ones that I didn't want to include. Like here where it says output FA, I actually just want the areas that says output F to be marked. But the reason why it's including this, now that I look at it, is because output FA includes output F within it. And when it sees output F, it simply stops. So if we want to be even more specific, what we can do is change these two instructions to say output /F and then open parenthesis, because that will eliminate the case where you have output FA open parenthesis. So to change an instruction, it's very simple. You can simply click on it, and then you can make your change, whether it's clicking on the down arrows to choose another instruction, or in this case, I'm going to change the expression that it's looking for. I'm going to call this output F open parenthesis, and then hit commit. So doing that one change actually solves the case. This is very specific, so it only looks for output F open parenthesis, and then the ending landmark within the file to let us know that we're at the end of the feature is still output /F. Now, if you notice as we scroll through the file, it seems to be picking that up for all of the nominal areas for the features. The reason why, what's happening is this instruction set is looping through for every time it sees new data or more of the file, it will continue to loop until it reaches the end of the file. Every time it loops through these instructions, the starting point is the ending point of the previous loop. So what this means, starting off, our marker is at the end of the header. The first instruction executes, search for the next string output /F. So it will look, it finds it here at this location. So then we say mark current position as begin. It does. Move to the next line. So our cursor moves down one line. Search for the next string output F here. So from this location, it will look and scan until it finds output F, which it does here. So it will stop, and then we say mark current position as end. So this is marked as the end, and the software will highlight everything between the beginning and the ending mark, which will be this block. So that's the first time through the loop. So when this executes again, it will execute from this new spot. So from this spot, it says search for the next string output /F open parenthesis. So here is FA, so it doesn't see that as matching this expression. It continues to look. The first time it sees this from this location will be here, which is the next feature. Output /F open parenthesis. So then the next instruction is mark current position as begin. Then it moves to the next line, looks for output F again, which it finds here, and then marks that as the end. And then this becomes the new beginning position the next time through this loop. So that happens over and over again throughout the file until the very end, marking all the areas that we want, but we only define what that area is one time within the feature instructions. So again, it's very important that we know what is consistent within our file's format in order to correctly write instructions that will always grab the right area for the data that we're looking for. So now that that's done, the next step will be just like we did for the header, which is we define our characteristics, which will pick up the data from this area. So to mark the characteristics for all of these features, again, they only have to be done once, but we have to grab or create one characteristic per type of data. So what type of data do we need to grab? Well, in this case, we have feature locations that have X, Y, and Z nominal positions. We have upper and lower tolerances, and we have also vector information, vectors being the IJK orientation or angle of approach that the probe would take to the surface at this location. Those will be identified either as 0, 1, or some number in between for X, Y, and Z, and the vectors for those would be I, J, and K. And then finally we have the feature name itself, or the unique ID for this specific location that has been measured. So we have feature ID, we have XYZ nominal, IJK nominal, and then we have upper and lower tolerances. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It looks like 13 unique pieces of data that we need to grab. So we need to create 13 characteristics to properly scan or pick up those 13 pieces. So let's start with the first one, which will be the feature name. It's found at that first line. What we can do here is right click on characteristics, choose new characteristic. And again, the color that it assigns is random. You can always change that. And the name for this, if I right click and go to modify characteristic, I will change this to reflect what I want to grab, which will be the feature label. I can change the color to whatever I want. Let's say I stick with orange for now. And then again, association is very important. This is where we define for the characteristic what it is we are having it pick up. So we're defining the data type so that the software knows where to put this piece of information into the database. So the feature label, if we go to associate here, again we have our three categories. We'll go here to feature, expand, go to properties, and then label. This will always be the proper data type for feature label. So there's a lot of different data types here, but again, each one of these is mapped to a certain type of data. And we, just from experience in how the software is set up, we know that feature labels or the tags or IDs for features should be associated here with feature properties label. So we're going to choose that, hit OK, and then we can start defining our instructions underneath. So the first instruction, again, will always start at the beginning of the section we're in. So it's going to be here at the beginning of the O. That's for each characteristic defined underneath this feature. That's the case. So for the first one, our cursor is starting off here. We want to get to between these two parentheses in order to pick up this feature ID. So what we can do, if we know that this never changes, we could count over and tell it to move a certain number of characters to get to this position. Or we can say search for open parenthesis here and then move one character, whichever works. There might be more than one way to define the instructions, which is fine as long as it's consistent and based on the file formatting internally, things that don't change. So what I'll say here is search for the next string, open parenthesis. That will move my cursor to the beginning of it right here. Then I will say move to next character one time. That moves my cursor once. So now I'm in front of where I want to start marking. Mark current position as begin. And I want to get to the end of this, which will be right in front of this closing parenthesis. So I can say search for the next string, closed parenthesis, commit. That puts me right in front of it, because remember, anything you search for, the cursor will stop right in front of it. So that means I'm in front of the closed parenthesis, but behind the 6, which is where I want to be, or behind whatever character that will be. So the last instruction will be mark current position as end. And doing that will define or always move us to the proper area to pick up the feature name from this feature area. So because these repeat, all the characteristics repeat once for every loop that the feature instructions repeat. So that means that it's going to define this feature label for every area within the file. All right, so that's one down. There'll be others that we want to do. For instance, we have the X, Y, and Z nominal. We have I, J, and K vectors, and then we have X, Y, and Z upper and lower tolerances. So you can define these in whatever order you want, but what I'll do is all the X values first, and then move on to the Y and then the Z. So to define the X values, I'm going to make a new characteristic. I'm going to double click here and call this X nominal. I'm going to choose a color for it and the association. So here the association will be under feature. In this case it will be characteristic. And what you see here is a list of predefined dimension types. So we have position, X, Y, Z, diameter, width, length, radius, distance, angle, gap, flush, normal, polar, azimuth, horizon, and then vector, IJK, U, V, W, and then some special cases for coordinates, and then what's known as user characteristics, which we'll probably look at later on. Those are for more generic types of data that you might want to load into the database that don't fit these other dimensional types. So if someone wanted to use the software for something other than just dimensional analysis, they could use these user characteristic types and define what each one represents, stick with that definition, and still use our software for SPC capabilities for those other types of data. But in this case, this is dimensional data, and we're trying to grab the X nominal, so we're going to go to X and then expand, and then underneath that we have the nominal data type. So we're going to click there. We'll see the association selected will be feature X nominal. We'll hit OK and OK. And now we have the X nominal characteristic defined. Now we need to define the instructions. So again, this is a new characteristic. The undefined instruction will start at the beginning of the section, which will be here, right behind the O. So the number for the X nominal, it will be found right after the second line where it says cart, C-A-R-T. There'll be a comma and then a number. That first number is the X nominal for this file format. The second number after the comma would be the Y nominal, and the third would be the Z. So in order to always get to this place, again, we don't search for the number itself, but we have to look for things that do not change from file to file that we can put in our instructions to get to this area. So in all these cases, the word cart appears and then there's the numbers. So maybe the first thing we can do is search for the word cart. So I will say search for the next string cart. Go ahead and hit commit. And that means that our cursor will go from here to here, right before the C. But what we want to do is get to this number. So that's the first instruction, just to get us on the same line. And then from this position, we know that that first number, or the X nominal, is always the first comma after this. So the next thing that we can say is, in this case, we can say locate the next character that is a comma one time. We could do that, or we could tell this search for the next string and then put in the type the comma key. Both things would do the same thing in this case, but I just want to show a new instruction, which is locate. Locate the next character that is a comma one time. That will put us here. We want to be to the right of that comma, so I will say move to next character one time. That will move us over one character position. At that point, I can say mark current position as begin. Then locate the next character that's a comma one time again, because that will put us here at this position. And if I hit new instruction, I can create a new instruction and at that point say mark current position as end. And that will mark that as the X nominal. Now, this is actually a good opportunity to show another type of instruction. There's always beginning and ending marks. There are also some shortcut instructions. If you notice here where it says mark the current position as begin, if I click to the arrow next to it, I have begin, end, and then I also have things like number, word, label, line, and cell. So these are shortcut cases that will allow you to do in one instruction what you would do in three. So number, mark the number. If your current position of the cursor in the software is touching a number to the left or to the right, using this will mark that number and look for any other character that is a number, that is considered a number type to the left and right of where it's marking to grab the whole number. The same thing applies to word, label, line, and then there's cell. Mark line means marking the entire line at once. And then cell is always about marking wherever the cursor position is, if it happens to be between two commas or two tabs. It will identify that as a cell area and then mark everything in between. So in this case, I'm noticing that for all of these numbers, there is cart, comma, number, comma, number, comma, number, and it repeats that for all of this. The end of the line is also considered the end of a cell, so it would still apply or be able to be used for numbers where there's just a comma and then the end of the line. So if I use that instead, what I can do is delete, and where it says mark the number as current position as begin, I could say mark cell at current position, and it would do the same thing. It would just mark between its current position, which is to the right of that first comma, all the way to the other comma, in order to mark that number. So that's marking the X value. So at this point, we might want to also guarantee that the number itself does not have any alpha characters within it, because that number is going to be stored in the database as either an integer or a real number, and we don't want any text to be stored for a number value. So to validate that, we can make sure that the software looks at what's being scanned and based on what it finds, allows the number to be loaded or notices that there's a format error and not scan that number. To do that, if we right click and go back to modify, next to associate, if we go to the right, there's something called type validation. So here is where we can choose the type of validation for what we've just picked up. So there's text, which allows anything to be scanned, integer, which just allows whole numbers, there's real, which allows decimals, and then there's date format, time format, and then date and time together. So in this case, we want to choose real decimal value because these numbers have decimals. So doing that, it still grabs our number, which is good. If this had a letter in any place of this area, then that field would not be scanned for that particular feature due to the validation. So that will help prevent wrong or data with errors format-wise of being loaded into the database. Okay, so let's go on to the X or the I vector, which is the vector for X. So we have X, Y, Z. The next group would be I, J, and K for these numbers. But to get to the I value, if we notice the distance between the X nominal and that, you have the call out called cart for Cartesian, and you have 1 comma the X value, 2 comma Y value, 3 comma Z value, 4th comma, and then that's the I vector right there. So it's 4 commas after the call out cart. So using that formatting consistency, what I'll do here is duplicate what I have and then make a change to it. So I'm going to duplicate this X nominal. I can right click and choose duplicate characteristic. It'll create a copy and have a parenthesis 1 for that copy. Right click, modify. I can change this to I vector. If I want to change the color slightly, I can do that as well. And then the association I definitely want to change. I'm going to change this from X nominal to down here where it says vector I nominal. Now if you noticed when I did that change, it's still highlighting the same area, but now it's lighter. We have 2 characteristics, but they have the same instruction set. So one is highlighting over the other. Whichever came last, that's the one that you see if they're highlighting the same area. So we need to change this in order to pick up where the I vector is. So as we saw before, it's 4 commas away from where it says cart. So instead of search for next string cart, locate the next character with a comma. It says 1 time. If I click here, I can click on the drop down to change this to 4 times. Hit commit on that. And then the rest of the instructions will execute and it moves over to the proper location for the I vector. So that it's I. The next thing we're going to grab for X data would be the upper and lower tolerances. So I'm going to follow the same procedure. This time I'm going to duplicate this. And then right click modify. I'm going to call this X upper tolerance. Again, this can be called anything you want. You could say X plus as a shorthand. That will work too. I'm going to change the color definition. In this case, I think I'll do yellow. And here where it says associate, this is going to be a bit specific here. So I'm going to go back to X for the feature characteristics X. And this is a spec limit that we're picking up, or specification limit. So I'm going to choose specification limit. There's different types. There's specification limit 2, which is the second set of tolerances that you can assign, reasonable limits, control limits, MSA. These are for control limits, MSA. If you those are calculated out of the software or within the software for correctly predicting things like CP or CPK or PP and PPK. But here for spec limits, that's the one we want for what we're picking up. And there's another category, there's absolute, where the spec limit is defined in relation to the origin of the reference frame that all of these dimensions are in. In this case, if we see for the spec limits where it has -1 +1 or 0.5 -0.5, yet the nominal is 13,024, probably in millimeters, we know that this 0.5 plus or minus is not in relation to the origin of the reference frame, or else a perfect hit on this location would always be out of tolerance. Instead, it refers to plus or minus 0.5 in relation to what this nominal is. So that means that these are, just by the look of it, these tolerances are relative tolerances to what the nominal values are. So if that's the case, if I go back here, I want to choose specification limit relative because it's relative to the nominal, and then it's bilateral because we have two, an upper and lower, and since the lower comes first, I'll choose that one. Actually, here I have X upper tolerance, so I want to choose the upper. I want to make sure this is consistent. So this is the characteristics for X upper tolerance. So we'll choose that option. Feature X specification limit relative bilateral upper. We'll hit OK. And what we'll do is modify these instructions to pick up that upper X limit value, which is on the line underneath. So here we have search for the next string cart. Actually, what we can do, if we look at what's consistent, it always has X-axis, Y-axis, Z-axis on the same line that the limits are on. So I could search for the next string X-axis in order for the cursor to be put in front of that and on the same line as the actual limit we're trying to pick up. So if I do that, and then from this point, if I look at where the upper tolerance value is, it's 2 commas away. So there's X-axis, comma, lower value, comma, upper value. So to get to the upper value, I have to go past 2 commas and then move 1 character to the right. So what I can do is say, locate the next character, that's a comma 2 times, then move to the next character, mark cell at current position, and now it's grabbing the right value. By the way, while you're developing, it's good to just hit save every once in a while to save your progress. What gets saved are the instructions that you are writing. If I close this out and open it back up, I'll have to load the file back in, but the instructions we are using to scan the file, those will be updated to the last thing you did before you saved. So we have the X here, and then if we want to pick up the X lower tolerance or spec limit, I'm going to duplicate this, and I can right click and say modify, or I can double click. If I double click, it's the same, a different method of doing the same thing, which is getting into this characteristic properties dialog. So here I will say X lower tolerance. Can change the color slightly. And then the association, instead of X spec limit relative bilateral upper, it will be lower. I'm just going to choose the option below. Hit OK. OK. And then if I expand that, this lower tolerance is 1 comma behind what the upper is. So I can click here, choose, locate the next character that's a comma 1 time, hit commit, and then I have the X spec limit for the lower value. So I've just picked up everything related to the X nominal. And if I wanted to do the Y nominal, I could, again, either make a new characteristic for the Y nominal, J vector, Y upper tolerance, and Y lower tolerance, and do that again, or I can duplicate this and make the same changes that I did for the other duplicates, but in this case I make the changes to pick up the Y value, associate with the Y association, and change the instructions to pick up again the Y value. So just as a very quick example, I can duplicate this X nominal, change this to Y nominal. I'll change the color, change the association from X nominal to Y nominal. Click OK. And then the instructions here, the Y nominal is 1 to the right. So instead of locate the next character that is a comma 1 time, I'll say 2 times for this. And there I've just created the Y nominal. And I do the same to create the J vector, the Y upper and lower spec, and then everything for Z. So I think you see with this example how you can develop the rest of what we need to pick up the Y axis, the Z axis, the Z nominal, and then the J and the K vector for this. Once that's all done, you would actually have a complete translator for your nominal for this file. And that would be used to upload the data to the database. So we'll take a break with this, and hopefully you can finish the rest of the instruction set for the characteristics we need, and then we'll continue on with uploading this data and onto the next type of format for this particular example for the sample files, as this is developed for the nominal file. So thank you for attending, and we'll stop here for now.